The Dissolution of the Old Synthesis. We have seen that there are classic religious periods when faith and knowledge have seemed to approximate to one another. The Middle Ages in Europe constituted such a period. No religion versus science controversy could then be said to exist. The best scientific knowledge of the time seemed to sanction the popular religious notions. Learned and lay thought in the same terms; the wolf lay down with the lamb. The Old World Scheme. It is important to grasp the main features of a world scheme which as late as the 15th century passed everywhere without criticism. The father of it was Aristotle. His conception of the universe rested upon the plain contrast, which strikes the unsophisticated observer, between the unembarrassed and regular movements of the heavenly bodies and the disordered agitations of sublunary things. Hence the heavenly region was eternal, and the region of earth transitory. Yonder the motions that take place are eternal and regular; here motion and rest alternate, nothing continueth in one stay. At the centre of the universe stands earth. Hence we mount through 3 sublunary strata to the region of the celestial ether, which is purer as distance from the earth increases. These strata form 3 concentric spheres, which, solid yet transparent, like crystal, revolve around the earth. The first contains the moon, like a fly in amber; the second, the sun; the third, the fixed stars, which last sphere is also the first of several successive heavens, the highest of which is the seat of Deity. The Aristotelio-Ptolemaic system formed a coherent framework for biblical world notions. Here, too, earth stands still while sun and stars revolve. Here, too, the seat of Deity is the highest heaven. This was an universe where men could feel their feet on firm ground. Their minds found rest in those simple and definite notions which make religious conceptions easy to understand and accept. Their imaginations were not yet disturbed and disquieted by thoughts of space and time, without end and without beginning. Aquinas. Such was the world of nature, the theatre for that "world of grace" which Revelation spoke of, and which led eventually to the eternal "world of glory," in which the faithful should have their portion. Natura, Gratia, Gloria was the ascending series, like another set of celestial spheres, and the whole economy was elaborated into a logical system known to the historians of thought as Scholasticism, a philosophy which found its most perfect and memorable expression in Thomas Aquinas (1227 74), the Doctor Angelicus of Catholic theology, canonized less than 50 years after his death. The Summa Philosophica, where Aquinas deals with the rational foundations of a Christian theism, and the Summa Theologica, where he erects his elaborate structure of theology and ethics, together constitute one of the most magnificent monuments of the human intellect, dwarfing all other bodies of theology into insignificance. In him the erudition of an epoch found its spokesman; he was the personification of an intellectual ideal. To his contemporaries he stood beyond the range of criticism. In the Paradiso it is St. Thomas who speaks in heaven. Nevertheless, the scholastic world scheme, though based on the evidence of the senses, the investigations of antiquity, and the authority of the Church, and though Aquinas had set the seal of finality upon it, was destined to gradual discredit and ultimate extinction. Disintegration begins. It was open to attack on 2 sides. Either observations or calculations might be brought forward conflicting with it or making another conception possible or probable, or the validity of conventional ideas of space might be disputed. The latter type of criticism was the first to occur. Nicholas Cusanus (1401 1464), an inhabitant of the Low Countries, subsequently bishop and cardinal, developed unconventional notions about space. He suggested that wherever man finds himself, on earth, sun, or star, he will always regard himself as standing at the centre of existence. There is, in fact, no point in the universe which might not appropriately be called its centre, and to say that the earth stands at the centre is only (what we should now call it) an anthropomorphism. So much for place. And similarly with motion. Here, too, there is no absolute standard to apply. Motion may exist, but be unnoticed if there be no spot at absolute rest from which to take bearings. We are like a man in a boat sailing with the stream, who does not know that the water is flowing, and who cannot see the banks. How is he to discover whether the boat is moving? Cusanus, in fact, denies the fundamental Aristotelian dogma that the earth is the central point of the universe, because, on general grounds, there can be no absolute central point. This gave a shock to the geocentric theory, from which it never recovered. Worse shocks, however, were to come. The name of the man who actually, as Luther complained, turned the world upside down, is notorious enough. Poles and Germans alike have claimed the nationality of Nicholas Copernicus (1473 1543), who, having been a student at Cracow and in Italy, became a prebendary in Frauenburg Cathedral. The new astronomy. The general criticisms of Cusanus were elaborated by Copernicus. The senses cannot inform us, when any motion takes place, what it is that moves. It may be the thing perceived that moves, or the percipient, or both. And it would be possible to account for the movements of celestial bodies by the supposition that it is the earth that moves, and not they. Copernicus' whole work consisted in the mathematical demonstration that this hypothesis could account for the phenomena as we observe them. In fact, when these demonstrations were eventually published, it was only on his deathbed that Copernicus received a copy of his book, and he had already lost consciousness. They were introduced by a discreet preface, which intimated that the whole thing might safely be regarded as a jeu d'esprit on the part of an eccentric mathematician. And this editorial caveto, though written by another hand, preserved the Copernican theories from the notoriety that might otherwise have attended, and afterwards did attend, them. Copernican conceptions were semi-traditional. The sun displaces the earth as the central point of the universe; around it revolve the planets, including the earth; and at an immeasurable distance is the immovable heaven of the fixed stars. Copernicus left it an open question whether or no the universe was infinite. It remained for his successor, the greatest of the Renaissance thinkers, Giordano Bruno (1548 1600), to declare it to be limitless, and to contain an infinity of worlds like our own. The fixed stars became, for him, suns surrounded by planets. The traditional distinction between the celestial and sublunary spheres had vanished. The bewilderment and indignation excited by these ideas, revolting to the conscience of his time, cost their author his life. Galileo. The criticism of the old world conceptions was, however, to be based on yet more sure ground by one who relied, not on general considerations, but on observation and experiment. Galileo (1564 1642) studied philosophy, physics, and mathematics at Pisa, and as professor expounded the old astronomy long after he had ceased to regard it as adequate. Not until 1610, after he had constructed a telescope and observed the satellites of Jupiter, did he openly confess his adherence to the system of Copernicus. The observation of sun spots and the phases of Venus confirmed his opinion. Aristotelian astronomers declined to witness these phenomena through his telescope, and perhaps Galileo was right in observing with a sigh that were the stars themselves to descend from heaven to bear him witness, his critics would remain obdurate. Footnote: Monks and theologians were betrayed into some controversial asperities. "Ye men of Galilee, why stand ye gazing up into heaven?" formed the appropriate text for a sermon by a Dominican. It was not until 1632 that a complete exposition of the conflict between the two world systems was produced by Galileo. It took the form of a dialogue between three speakers: conservative, mediating, and extreme. The views of the author, however, were not sufficiently concealed; the book was prohibited, and Galileo summoned to Rome, and upon threat of torture, subdued into a recantation and a promise not to offend in the future. That Galileo perjured himself is not open to doubt, nor did he change his convictions. A subsequent work, surreptitiously printed in Holland, contained the same heresies, expressed with less reserve. The new physics. It might be said, then, that the fabric of the universe had been reconstructed by the thinkers whose explorations we have hitherto followed. This achievement, however, though sufficiently startling in itself, was not the only, and perhaps not the most important, of their performances. The question still awaited solution: By what forces and laws is the new world system maintained in activity? The traditional reply had been that the universe was kept in motion by the operation of the Deity. While the truth of this reply was not questioned by the advocates of the new science, it did not seem to them to dispel the obscurity surrounding certain points about which they required information. It was Galileo who observed that the appeal to the divine will explains nothing just because it explains everything. It takes the inquirer back too far, behind those details of method which arouse his speculative interest. This desire to understand those methods of operation which natural objects appear to follow led philosophers to enunciate certain laws about them. These served as explanations of particular classes of phenomena. It was the phenomena of motion that especially attracted their attention, and many ingenious experiments were performed by Galileo, in particular, which led him to conclusions which then seemed paradoxical, but now serve as axioms of physical science. For the laws of motion contain the key to all scientific knowledge of material nature. When Galileo, after careful experiment, established the proposition that a body can neither change its motion of itself, nor pass from motion to rest, the fundamental law of inertia, of such incalculable importance to the development of modern physics, had been established. An automatic universe. A proposition of this kind may not at first seem to involve important philosophical or theological consequences. But we only have to consider that it provided a natural explanation of the continued and untiring motion of the heavenly bodies. It did not, it is true, explain how that motion arose; but the motion being given, it had now been shown how it would, in the absence of obstructions, be perpetual. In fact, speculations of this kind opened up the way to the mechanical explanation of nature, a theory which had been already speculatively held by Leonardo da Vinci, who was already convinced that necessity is the eternal bond, the eternal rule of nature. Science and mathematics. It was not only, however, the spectacle of a system running automatically that suggested to observers a mechanical theory to explain it. There was also the fact that phenomena were observed to occur in accordance with certain simple mathematical laws. Galileo's experiments with falling bodies led him to foreshadow principles which were afterwards elaborated and fully demonstrated by Newton, who may be said to have been the first to construct a mechanical universe. The principle had already been formulated by a contemporary of Galileo, Johannes Kepler, in the axiom ubi materia, ibi geometria. Results. The thinkers whose speculations have engaged us were indeed responsible for creating a revolution in ideas. For a finite universe whose centre was the earth, and which was kept in motion by the operation of the Deity, they had substituted the conception of illimitable space sown with innumerable systems like our own, and had created the beginning of a mechanical conception of nature. The new logic. But it was not only the scientific dogmas of the old system that had been so rudely overthrown. The very principles upon which those dogmas rested had been submitted to a destructive criticism. The new science produced a new logic. This order of events is not unusual. First, the new scientific discoveries, and then in the wake of the discoverers comes the innovating critic who systematizes the logical or scientific methods to which the new knowledge seems to have been due. First Kepler and Galileo, who used the inductive method, and then Lord Bacon of Verulam (1561 1626), who discovered the inductive logic and established it as a system. Francis Bacon. Bacon's doctrine may be summarized by his own epigram: "If a man begin with certainties, he shall end in doubts; but if he be content to begin with doubts, he shall end in certainties," which is really a criticism of what is known as the a priori method, whereby the inquirer starts with certain predefined theories to which all phenomena must conform, and which all experience must verify. If facts will not suit the particular theory, so much the worse for the facts; one could always disregard them, and apply a blind eye to Galileo's telescope. Such is always the procedure of the dogmatic mind, which is already so certain of the truth of its notions that no evidence can persuade it to the contrary. But it is not by such means that knowledge is advanced, and it was for a reversal of these that Bacon pleaded. Leonardo da Vinci had already anticipated the Baconian logic (which did not wait for Bacon until it was applied), when he laid down the proposition that wisdom was the daughter of experience, and rejected all speculations which experience (the common mother of all sciences) could not confirm. Hence knowledge was the product of time; the process of collecting material for a judgment must often be slow, but the results were worth the labour. These would not be speculative, but true. Nor need it be supposed that Bacon excluded imagination from playing a part in increasing knowledge. He did not plead only for a mechanical collection of material. It is imagination which in face of abundant material creates the hypothesis which accounts for it being what it is. And he was prepared to admit the value of preliminary hypotheses which might be replaced as further facts were collected, or as insight became more clear. Here, too, Bacon describes the method followed by modern science. Prestige of new methods. And so, by the time when Bacon had laid down his pen after writing the New Logic, the work of discrediting the old system, elaborated with such ingenious industry by Aquinas, was tolerably complete. The new science had begun already to be fruitful in results, both practical and speculative. The successors of Galileo and of Bacon applied the new principles with vigour, and reached astonishing results. Justified by these, the new methods secured a prestige which has not decreased for 3 centuries. End of chapter 2.